let's say this is going to be our distance in centimeters. All right. And then we're going to have our wire. Average wire twist angle. This is going to be in degrees. So let's go ahead and pull this off. This is equal to this. This one is going to be equal to the average. These. I think we discovered that if I do this, I can just paste this here. And we see that our handle on this is a little bit better. All right, so we were supposed to stop at 6, but I went on into 4 centimeters. And if I try to follow what I did here, probably we did our prediction first. So let's go ahead and predict. Makes sense to me. So in this case, we're going to need a spring constant. No, Coulomb's constant. So I'm just going to say equal to, I'm going to go back to that sheet. Here's Coulomb's constant. Instead of me having to write everything, well, looks like I'm going to have to do it anyway. Coulomb's constant. And this is in newtons meters squared. I'm going to see if I can hit my F4 key. Squared. F4 2. No, that's not working. All right. Just behave. 2. Divided by capital C. Okay. All right, so we have Coulomb's constant. Now I can just go back and refer to the actual value. I could type it in, but I might at some point want to put in the actual number. So we have Coulomb's constant, and then we know that this is going to have a voltage. It's just going to have a set voltage, and I believe that I set it to just 6,000. Okay. 6,000 volts. And so our prediction, we need our charge. Okay. Quite literally. We need our charge. So we are going to need the radius of the sphere. And that's going to be in meters. So I'll just go ahead and acquire that information. And that is over here, radius of the sphere. And let's see here. After we have our radius of the sphere, we have voltage, we have radius, and we have Coulomb's constant. So we need to calculate the charge. And this is just going to be equal to voltage times the radius divided by Coulomb's constant again. So we have the charge on the spheres, and we need to square that. I doing this? C superscript squared. All right. So that's just going to be equal to the power of this value, comma 2. All right. So this is the charge. So now we want to find what we're expecting. So this is our expected value. And this is just equal to Coulomb's constant times charge squared. This is the expected value. Oh my gosh. Okay. And this is again, this is going to be what is this? This is going to be Newton. I'll delete it. But I'm just going to write it. I think it's a mistake. Newton meters squared. Because I said this was going to be the case for the last one. Something should change. So I hadn't really thought about it. Okay. So the first one was Newton over 1 over meter squared. Nope. It was a Newton meter squared over Coulomb squared divided by 1 over meter squared. And so if I multiply the denominator by meter squared, I have to multiply the numerator by meter squared. So that's going to be meters cubed, meters quartic. All right. So in the last one here, this is actually quartic. I'm kind of jumping around a little bit here. Just wanting to correct this mistake. So this is 4. Why isn't this doing it? 4. Oh, look, a watch. Oh, no, that's right. Okay. And then I want to remove it. Divided by C squared. Just seems super weird, but it is. There you go. All right, so let's get back over here to distance. So this should be correct. All right. All right. So this is our expected value. I'm just going to go ahead and highlight this. I'll put it in green. And now let's go ahead and bring our distance. We're going to convert that over. I didn't convert that over, but I'm going to convert it here. So it's going to be distance in meters. So this is going to be equal to convert. Excuse me. All right. So that makes sense. And uh, you know what? Before I do that, I'm just going to say equals to 20. It's just going to be more difficult for me to manage this if I don't put this like this. Equals to 9, equals to 8, equals to 7, equals to 6, equals to 5, equals to 4. Okay. And see the angle, average wire twist angle. Should I convert that now? I think I will. Distance in meters. Convert. Select, comma, centimeters to meters. And I'll just bring this down like so. Let's go ahead and just give it the same amount of decimal places there. You can actually read